AI agents don't actually think like humans. Behind the curtain, they run a hyper-fast cognitive cycle that turns vague goals into concrete real-world decisions.
Let's start with how an agent perceives your instructions. When you type a prompt, the agent doesn't see friendly words. It ingests your goal, checks its system rules, and unpacks the current context. First, it parses your intent, extracts key variables, and establishes boundaries before generating a single move. Think of this as setting up a digital sandbox. The agent locks down what it can touch, what it cannot do, and what success actually looks like. Without this intake step, an AI would drift off course instantly. Context is the anchor holding its focus in place. Once the ground rules are established, the real decision machinery wakes up.
Now we enter the core engine of decision-making. Standard language models just guess the next word, but an autonomous agent runs what researchers call the react loop, alternating between reasoning and acting. It generates an internal thought, commits to an action, observes the result, and repeats the cycle continuously. This internal scratchpad changes everything. Instead of rushing to an answer, the agent asks itself, what piece of data am I still missing? Every loop updates its understanding. If a search comes back empty, the agent notes the gap and recalculates its trajectory. It's not intuition, it's iterative problem-solving executed in milliseconds.
Next, let's look at how agents touch the outside world. An isolated model can only talk. An agent can act because it is equipped with a digital tool belt of software functions and live APIs. The agent evaluates its goal, selects a matching tool schema, sends structured data, and awaits real-world feedback. It matches what it needs with JSON schemas describing each tool. If it needs flight prices, it formats the exact code required to query an airline API. The external server executes the request and hands back raw data. The agent treats that output as a fresh observation. Tools transform a passive text generator into an active operator capable of executing complex workflows.
To make smart choices over time, agents need memory. Agents operate with two distinct memory layers. Short-term memory lives directly inside the active prompt window, tracking immediate progress step by step. Meanwhile, long-term memory queries external vector databases, retrieving relevant past experiences and feeding them back into the active context. This dual system prevents cognitive overload. The agent doesn't carry every past conversation. It pulls only what matters for the task right in front of it. When a past mistake is retrieved from storage, the agent incorporates that lesson directly into its current reasoning chain. Memory bridges isolated actions into a coherent, long-term strategy.
Finally, how does an agent know when to stop? Autonomous agents fail frequently when tools return error codes, but instead of crashing, advanced agents trigger reflection routines to analyze what went wrong. An error occurs, the agent inspects the stack trace, adjusts its parameters, and executes a corrected attempt. Hard guardrails run in parallel. Strict token caps and safety filters prevent the agent from getting trapped in infinite runaway loops. Once the agent validates that all sub-goals meet its completion threshold, it produces the final answer and powers down. Every output you see is the culmination of dozens of small, self-regulated micro-decisions. AI decision-making isn't magic, it's an engineering loop of observation, action, and rapid self-correction. Save this breakdown to master the mechanics behind autonomous systems.